For each of the following conditions, is it possible to construct two non-congruent triangles? Explain why or why not. So part A triangle with angles measuring 60 and 70 and an included side of 8. So let's try it out here in part A. So I'm going to draw a triangle. So it's got a 60, a 70, and an included, meaning between it, side of 8. So that 8 is between the 60 and the 70. So it's got a 60, a 70, and an included side of 8. Could you make, so the question they're asking us is, could you make another triangle that's like different, it's not identical, that also has a 60, 70, and a side between? Could you have two that are not identical but have those pieces the same, right? Two non-congruent. Congruent means identical. So the question is, can we have two non-identical, non-congruent triangles with these facts that have those two angles and the side in between? Can that be the case? No. These must be identical because of angle, side, angle. They both have the same angle, side, and angle. By angle, side, angle, they must be identical, meaning congruent. That's what identical, that's what congruent means, is identical. So they have to be congruent. They have to be identical by angle, side, angle. So no, it is not possible because any two triangles with these conditions are congruent by angle, side, angle. Remember, every three-letter combination except for AAA and the bad word, ASS, all the other three-letter combos make two triangles identical. Let's try the next part down here. Part B. It says for part B, a triangle with angles measuring 60, 70, and a non-included side of 8 on a side of the 60-degree angle. Okay. So let me see if I can draw that. So, and then let me write what we got. So we want two of these. So let me put another one over here. So we're wondering, is this possible? So on this first one, we've got, what do we got? Angles measuring 60, 70. So we got like a 60 and a 70. And a non-included side. So some side over here like 8 or something. Oh, 8 that's on the side of the 60. Oh, it can't be there. It'd have to be like down there. It's got to be on the side of the 60. That makes sense. It had to be one of these two because that's a side of the 60, but it can't be between. It's non-included, so it'd have to be down there. So can you also have a 60, 70, and an 8 down there? Can you have that and those two be different? No. They must be identical, congruent. Why? By, what's the relationship we have going on here? This is side, angle, angle, right? Angle, angle, side. The side is not between the A's, so we call it angle, angle, side. You don't put the side between them. It isn't like the part A where the side was between the angles. They specifically said non-included. It's not included between them. It's angle, angle, side. So it's part A. It is not possible to make two different triangles because they would be the same triangle. They would be identical by angle, angle, side. They really have to be the same triangle. They can't be different. It's impossible to make two different triangles with those characteristics. They got to be identical, congruent by angle, angle, side. Last part, see? They're saying a triangle with angles measuring 30, 70, and 80. 30, 70, and 80. So I'm going to come down here, make a triangle like this, and then make another triangle like that. Now those two are different sizes. And this one has a 30, a 70 and an 80. This one has a 30, a 70 and an 80. So they're two triangles, and they have the same angle, 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 but that's not enough. Remember, that's not enough to prove they're identical. So our answer is, our answer to this one is yes, they could be different sizes, right? The triangles could be different sizes. They've got to be the same shape. Remember, angle, angle, angle proves similarity. They're similar, meaning they're the same shape, but one could be a bigger version of than the other. Same shape, different sizes is our answer. So that's down here on D. It is possible that they could be different because the given conditions determine a unique shape, but not a size. Angle, angle, angle is only enough to prove similarity. It doesn't mean they're fully identical in every way. So they could be different triangles that both have the same three angles, same shape, but different size.